Good morning. Today we'll be reviewing for Chapter 2's math test. Write the values in order from least to greatest. Before I can do that, I need to make sure that they're all the same. The easiest is to change the fractions into decimals. So in order to do that, I'm going to take 3/4, and that is essentially saying 3 divided by 4. 4 can't go into 3, so I add my decimal and my 0, put my decimal above. 4 goes into 30 7 times. 7 times 4 is 28. I subtract. I get 2. Add a 0. Bring it down. 4 goes into 20 5 times, and it goes in evenly. So 3/4 is the same thing as saying 0.75. Let's erase this. All right, or 75 hundredths. Let's do the next one. So we have 5 divided by 8. 8 can't go into 5, so I add my decimal and my 0. 8 goes into 50 5 times. 5 times 8 is 40. But 40 is not going to be enough because I'll get 10, which obviously you can go in again. So let's try 6 times instead. And 6 times 8 is 48. And when I subtract, I get 2, much better. So I'm going to add my 0. Bring it down. 8 goes into 20. 2 times is 16. Subtract, I get 4. Add another 0 and bring it down. So 8 goes into 45 times, and it goes in evenly. So 5/8 is the same thing as 625 hundredths or thousandths. Let's erase this. Now we can actually compare the numbers. So as I'm looking, I have 0.4, 0.7, 0.6, and 0.5. So 0.45 is going to go first because 4 comes before the other numbers, right? And now I'm looking again. So now I have 0.7, 0.6, and 0.5. Well, 5 is smaller than 6 or 7, so 0.5 is going to go next. So 0.5. And now looking at these, I have 7 and a 6. Obviously 6 is going to go first, so that's going to be 5/8. And then not last but not least is going to be 0.75, which was 3/4. Okay, again on this next one, in order to compare the numbers, I need to actually make them be the same. So I already did 3/4 up here, and we know 3/4 is 0.75, so I'm not going to do that out again. I'm just going to put 0.75. Obviously 0.75 and 0.75 is the same, so I'm going to circle equal. I'm going to need to convert this into a decimal. In order to do that first, though, I'm going to need to convert it into a mixed number. So I have 5 times 1, which is 5, plus 3 is 8, so I have 8/5. And remember, I did that problem as well. 5/8 was 0.625. Okay, and so as I'm looking, I have 0.625 and 1.9. So that 1 is a whole number, and there's no whole number here, so we know that this side is going to be greater. Looking over here, we have 4/5 and 0.325, or 325 thousandths. So we've got 4 divided by 5. 5 can't go into 4, so I add my 0, my point. 5 goes into 48 times. Subtract, I get 0. So this is 0.8, and I'm comparing it to 0.3. 0.8 is a bigger number, so I'm going to circle the greater than sign. Over here, again, I have to convert the 7 2/5. Before I can convert it into a decimal, I have to convert it into an improper fraction. So 7 times 5 is 35, plus the 2 is 37. So we have 37/5. So again, we have to turn it into a decimal so we can figure this out. So we have 5 divided by 37. 37 can't go into 5, but it can go into 50. It goes in one time. Let me erase this here so I can do it all the way out. Okay, so 37 goes into 51 times. So I'm going to subtract 10 from that's 3, and that's a 4. So I get 1. I have 13. I add another 0. I bring it down. I have 130. So I can kind of round it a little. I mean, I know 37 is close to 40. We got 140 here. It's about, 2 40s, a little more than that in 100, and then another 40. So we could try 3, but let's try 4 just to see. So 37 times 4 is 28, and then we have 12, 13, 14. So that is too much. So let's try 37 times 3 and see what we get. 37 times 3. 7 times 3 is 21. 3 times 3 is 9. Plus the 2 is 11. So we have 111, and we're going to subtract. So let's put my 3 here. Subtract that. I get 19. Add a 0. Bring it down. So now I'm at 190. Well, 4 was 148. Let's see how many times. I don't know. Let's try 5 times. 37 times 5. We get 35. We get 15, 16, 17, 18, 185. So there we go. 185. When I subtract, I get 5, I get 1. So now we're back to 150, which if you look up here, 148, so that's 4. We've probably gone far enough, though, to determine. So let's try this. We have 0.1354. Whoops. 0.1354 is this one. And we're comparing it to a whole number 7. If we're comparing this to a whole number 7, and this doesn't even have a whole number, we didn't even have to go that far to know, right? We know this side's going to be greater for sure. Okay, let's move this up. The table here, it shows the sycamore trees and our oak tree and our maple tree and our birch tree and the height. It looks like we're going to be comparing these things, so it's better if we have them all in the same. And our birch tree is not in a fraction, the others are. We could convert all of these to decimals, but since we only have one that's not in a decimal, it might be easier to just convert this one into a fraction. So we have 15 wholes, and then 0.72. 0.72. Well, if I look at that, that's saying that I have 72, and this is the tenths, and that's the hundredths. So I have 72 hundredths. And I can reduce that a little, because I know that 4 goes into 72 18 times. And I know that 4 goes into 125 times. So I can have 15, 18 25s there. So this will kind of help me. Okay. This will help me compare them a little bit more. So looking at the first question, it asks, the oak tree is the shortest. Well, the oak tree has a whole number of 14. The sycamore has 15. The maple has 15. And the birch has 15. So they all have bigger whole numbers. We don't even have to look at the fractions. So yes, the oak tree is definitely the shortest. Well, unfortunately, for comparing the tallest, because we have 3 that are 15, it's going to be a little bit harder when I'm looking at 18 25s, 3/4, and 2/3. So honestly, I think taking this back to a decimal is going to be my better option. I know 3/4, because of what I did before, is going to be 0.75, right? So on all these, it's going to be 0.75. So this will be 14.75, 15.75. And then with 2/3, we haven't done that one yet, but it's basically 2 divided by 3. 3 can't go into 2, so I add my decimal. 3 goes into 20 6 times. That's 18. I subtract, I get 2. 0 again, bring it down. It's 6 times. It's going to keep repeating, so it's going to be 0.66. So this is going to be 15.66, 14.75, 15.75. And then we already had over here, let me erase it, 15.72. So as I'm looking, I'm going to look at the first number first. We already know the 15s are the same. So now I have a 6, I have a 7, and I have a 7, right? So the 7s are going to be my 2 bigger ones. It's going to be between these 2. And then I have a 5 here and a 2 here, so the 5 is bigger than the 2, so it's actually going to be the maple tree is the bigger, not the birch. So this answer is false. The 2 trees that are the same, 2 of the trees are the same height. Well, we have 15.66, 14.75, 15.75, and 15.72, so that is false. These 2 are very close. They're just off by 100th. Or 3/100ths. The sycamore tree is taller than the maple tree. So here's my sycamore tree, 15.66. My maple tree is 15.75. Well, the 7 is bigger than the 6. So that is false. So point A represents, so it's asking if point A represents 1.0. Well, there's 1.0 and there's point A, so I'm going to say no. Point B represents 3/10, so there's point B, and we have 2/10 and 4/10, so this is yes, 3/10. Point C represents 6 and 0.5. So it's saying point C represents 6 and 5. Well, whole number's right here, so it would have to be way down the number line to be 6.5. This one actually represents 0.7, so the answer to that is no. Point D represents 4/5, so here's my point D. And they want to know if it represents 4/5. So currently the decimal for it is 0.8. And if I look, we're breaking this apart in fifths. There's 1/5. And then we have 2/5, 3/5, and 4/5. So yes, it is 4/5, because then that would be 5/5. Okay, next it says select the values that are equivalent to 1/25 and mark all that apply. So 1/25, so there's 1/25. See here, 1/25. 25, nope. 400ths is equivalent to 1/25, and 25 thousandths, no. This table shows Lily's homework assignment. Lily's teacher instructed the class to simplify each expression by dividing the numerator and denominator by the greatest common factor. Complete the table by simplifying each expression and then finding the product. So first I have to look, can I simplify 5? Can I cross multiply 5 and 1? I can't. But 2 and 4 I can, because 2 goes into itself and 2 goes into 4. So 2 goes into 2 one time and 2 goes into 4 2 times. So I'm going to get 1/5 times 1/2. And then if I do the product of that, 1 times 1 is 1, 5 times 2 is 10. Moving on, 5 and 5 can go into each other. 5 goes into 5 one time, 5 goes into 5 one time. 4 and 8, those can also be cross-canceled. 4 goes into 4, and I do it with the number 4. 4 goes into 4 one time, 4 goes into 8 2 times. So I get 1/1 times 1/2. And then when I do the product, I get 1 times 1 is 1, 2 times 1 is 2. Moving over here, 7 and 5 cannot be simplified, or cannot be cross-canceled, and 8 and 3 can't either. So I'm simply going to write them out the way they are because they can't be simplified. 3 times 5 is 15, and 7 times 8 is 56. Over here, the 9 and the 3 can be cross-canceled using the number 3. 3 goes into 3 one time, 3 goes into 9 3 times. The 4 and the 6 can also be cross-canceled. 4 goes into 4 one time, and 4 goes into 16 4 times. So now I have 1/3 times 1/4. 1 times 1 is 1. 3 times 4 is 12. Problem 7. 2/5 of the fish in Gary's fish tank are guppies. 1/4 of the guppies are red. What fraction in Gary's fish tank are red guppies? Show your work. Well, we know 2/5 of the fish, right, in Gary's tank are guppies. And 1/4 of those guppies are red. So if I multiply those, I'll be able to find out what 1/4 of 2/5 is. I can cross-cancel before I get started, just so it's easier. I know 2 and 4 can cross-cancel. 2 goes into 2 one time, 2 goes into 4 2 times. So now I have 1 times 1, and I have 2 times 5, which is 10. So the answer is 1/10 of the fish in Gary's fish tank are red guppies. So 1/10 are red guppies. All right, next question. 1/3 of the students at Findlay High School play sports. 2/5 of the students who play sports are girls. What fraction of all students who play girls are sports? Use numbers or words to explain. Well, if I've got, it's the same problem I had up here. I have 2/5, so 1/3 of them play sports. So 1/3 play sports, and 2/5 are girls. So if I multiply them together, I should get the fraction of students who are girls. There's no cross-canceling because 5 and 1 can't cross-cancel, and neither can 2 and 3, so it should be a number that doesn't need simplifying. So 2 times 1 is 2, and 3 times 5 is 15. So that means 2/15 of all students who are girls play sports. Okay, next they want us to draw a model to find the quotient. So we have 3/4 divided by 2. So right here, that's my 3/4, and then if I'm dividing them by 2, so let's divide them by 2. So there's my 3/4. I'm going to divide by 2, divide by 2, divide by 2. So this is 1/4, 1/4, 1/4. Half of 1/4 is 1/8, so 2/8 equal 1/4, right? So we have 1/8, 1/8, 1/8, 1/8. So if I want to get half of this 3/4, right? So if this is my 3/4, this is the halfway mark. So that means I have 1/8, 2/8, 3/8 in half, right? 3/8 in half of it. If you're using the number line model, we have 3/4 divided by 3/8. So here's my 3/4 mark, and I'm dividing it by 3/8. So we've got 1, 2, so 3/8. So there's 3/8. That's 1/8, 1/8, 1/8, right? And then here's another 3/8. 1, 2, 3. There's my other 3/8, because these are each an eighth. Okay, so how many 3/8 do I have? I have 1, 2, right? I have 2 3/8. Now, how are the models alike and how are they different? Well, both models show 3/4, but one model uses fraction strips, which is this one, and this one is using a number line. The fraction strip model shows how much in each group if 3/4 is shared among 2 groups, and the number line shows how many groups of 3/8 are in 3/4. Explain how to use a model to find the quotient 2 1/2 divided by 2. Well, the way you use a model is first you're going to draw 2 rectangles because that's your 2 holes, right? So there's my 2 holes. So I'm going to draw 2 rectangles. There's my 2 holes. And then a half because I have a half. So I have 2 1/2. And then I'm going to divide them by 2. So if I cut this one in half by 2, that one in half by 2, and this one in half by 2, I'm going to get a half here and a half here, which is a whole, and I'm going to get a quarter. So I have 1 1/4.